Hi everyone, welcome to the episode 3 of Building an AI Agent for ERPNext by ERP Gulf. In the episode 2, we discussed about Retrieval Augmented Generation, RAG. In this video, we will explain the technical implementation, how we fine-tune the retrieving model, which is the embedding model, how we push the model to Hugging Face, how we deploy the model via the replicate. Let's begin. The first stage is we need to prepare the training data to train the embedding model. We are using the base model, Modern Bird Embed Base Model by Nomic AI. Now, in order to, this is already an embedding model. It is trained on a large amount of general data, but it does not know our own schema or ERP specific domain. It does not know how to map a user question to its own tables or fields or custom data. That's why we need to train the model. So we need to prepare training data. I will show you the format of our training data. We are using this format. We have an anchor and positives. Anchor is a user question and positive collection of meta needed to generate the SQL. That means the table, fields and the joins. Whenever the question contain any master value, identifier or names, we have to mention the master data along with the positives. Now let's copy this. We are preparing the data custom, so we are depending on an AI tool like ChatGPT to create a data. You can give 10 or 20 questions or 30 questions. You need to specify the business areas. Okay, finally model gave the data set, but make sure to evaluate your positives, the tables and fields. You see leave application, model gave a leave application doc type. Let me check if that is a valid doc type in my test QI. I'm going to search for it. See, there is no doc type for called leave application. Make sure no fields and no tables like salary slip, leave application. If they are not in your records, you cannot add that in your training data. Now I'm going to copy this. And the second stage is once you have to, similarly you can generate 20, 100 and thousands of training data covering different modules. You can change these modules like that. But before going to the next stage, we have to make sure, even for a question like this, items that are currently out of stock, different people ask in their style, different styles can be there. So I'm asking ChatGPT to give me different messy variants. Different messy variants. Look, model is giving different variants like items that are out of stock, products with a zero stock, items with a stock balance 0, items with empty stock, item stock is 0, item not present in bin, item where quantity 0. You see different noisy, messy type is there. So model needs to understand them, these types too. So that's why we are generating for every questions we generated here, we generate a messy variant for each of them. We generate 10 to 20 messy variants for each of these records. So for that, we are using a synthetic data code and we are sending a request to OpenAI to generate the messy variants. We send each and every questions from this array We pass it to OpenAI, and OpenAI will generate the multiple 5 or 10 based on your preference, 5 or 10 messy variants, and finally you can paste it in your training data. I will show you a sample example. We are using Collab. The reason why we are using Collab, because Collab gives you good performing GPUs, and as we need to train our model, we have a billions of data, right? In order to train our model, we need to have a very good performing GPU. If you run your models training in your CPU, that means in your local computer, it can take too much time. So that's why we are depending upon a Collab environment with a Pro Plus subscription in order to run our model. Now, this is a synthetic data generation code. We are using the OpenAI API key to send the request and generate the messy variants. And we pasted the data we generated using this ChatGPT. And then we can pass a prompt template, discuss, it says about the context, templates, and how the messy rewrite should look like. We take each and every anchors, and then finally we get a query listed with the messy variants. We are using GPT for mini version, and once we run this, our synthetic data successfully generate the 60 variants for each and every questions we pasted in the list. Now we can copy that. Once we copy it, we can paste it on our main training data like this. This is how we generate our training data set. Once we have about 10K or 20K or 5K, you can start fine tuning. That means training your model. So I think you understood what is training data and how we prepare training data, how to generate train data, and how to generate synthetic data for messy variants. Now the third stages, I think these two stages are clear. Now moving to the third stage, which is schema preparation. How to prepare the schema. That means how to generate the enriched schema and how to generate the master data file. Now I will show you a template of the storage schema, the row schema. This is how the storage schema look like with the doc type. This is the MySQL format. Now you can see name, creation, every fields would be listed here. But here they don't mention the description of the table or the fields and joins, option values. We cannot get the details of these things with the storage schema. That's why we need to convert the storage schema to its enriched version. That means adding details of tables, details of fields, and adding join chunks, and also adding the option values. I will show you the enriched schema template. This is the enriched schema. You can see this is table employee. We are adding some synonyms and description about the table, its purpose, and its details. We adding field chunks, name like creation, modified, even the custom fields. We provide a small description about the role of this every fields. We also give options, naming series. Since it's a select type, we have to add the exact option values. Also, we also provide we also give the join chunks. This is the table employee gender field, which maps to gender doc type. Now how we generate it. Currently we are generating with the help of the ChatGPT or any other AI tool. We copy the storage schema. We copy one of the table's complete schema. Then we ask this ChatGPT to give the enriched version. If you want, you can copy a sample template of this and ask that tool to give the respective format. This is a very time consuming process, as you need to create this enriched schema for each and every doc types in your storage schema. But we are planning to make it automated with the help of an AI tool. Now, moving to master data. I think you know what is a master data. We already mentioned in the previous episode. Master data stores each and every records of master tables like customer, item, supplier, currency, all of that. Currently, we are generating this master data manually by getting the records from our doc types, and we will automate this process too in the coming versions. I think you understood what is enriched schema, how we generate it, and how we generate the master data file. Now the fourth step is moving to fine tuning. That means model training. How we are training the model. Let me show you Hugging Face. Hugging Face is a repo for storing different AI models. You can upload data set for training these models. There are different spaces to showcase your AI model, community for discussions. We are using Nomic AI's modern but embed based model. This was our base model, and this model is already trained on a huge amount of data. It already knows semantic similarity, semantic search based task, but it is not fine-tuned for ERP specific domain. It does not understand your custom tables or your custom fields, all of that. So we need to train it. Now we are going to the training stage. I will show you the training code. So this is our training code. So before going to training code, you have to make sure your training data. This is my training data. You can upload it here by clicking on this button. You can upload your own training data and you need to pass that path here. Then you can run this. This is actually for deduplicating the records. If your training file have any kind of duplicates, you can remove it with this code. After deduplicating your files, your training files, you can then start training. Now you need to have a Hugging Face account first of all. Then you need to create the access token in Hugging Face. After generating your access token, you can start fine tuning. You can create your own model repo, then start fine tuning. Inside this access token, you need to go and click on create new token. Okay, and then create token. Once you create your token, you can go to your profile settings, then click on new model, and you can name your model anything like testing one or something like that. You can choose any license and provide a proper model name, then you can create your model. This is how we actually create a Hugging Face model. Once you run this, you will get the model repo created. You can pass this as the model repo. After that, you can start fine tuning a model with the training data and the validation data. Validation data, this will evaluate the model, its performance, and it can also be used for checking if the model is performing well on unseen data. It will have a collection of questions that is not present in your training data. So through this validation data, by evaluation, we can find whether the model is generalizing on unseen questions or it is memorizing. Now we can provide an output directory path where our fine-tuned model gets saved. Now we are providing a batch size. These are different parameters that is used for fine-tuning. Epochs is actually, when we set 6 as epoch, that means it will undergo the whole training data set 6 times. 2e minus 5 this is a learning rate that controls the learning process of the model, the training of the model. And here this evaluator function will start evaluating our model before starting to train in order to check the before and after, comparing before training and after training. That's why we are running a evaluator before training the model. And there are different metrics like MRR, NDCG, accuracy, precision, recall. MRR will check how quickly the model gives the first correct answer. MRR, NDCG, precision, accuracy, recall. Multiple evaluating matrices can be there. MRR is used for will calculate how quickly model gave the first right answer, and NDCG calculate does the right answers are ranked top when compared to the less wrong results, I mean less relevant ones. And precision checks from the total correct answers how many were actually right. And accuracy checks at least one correct answers in the top K. Recall checks out of the total model given how many were right. These are the different metrics that's used to evaluate the model's performance. Now here we are loading the base model and using the sentence transformer library. We are also initializing the loss function. So I will explain what is a loss function. Okay, explaining about this loss function in the training data, I mean in the training code. Suppose in an embedding space, let's imagine this is an embedding space. And in an embedding space, we have the user question, right? So this is a user question. And we convert this user question during training in our Anger, you see, where is it? Yeah, we convert this whole user question into vectors during training, also during testing. And this vector, we can represent it here. Let's see if this is some values like this, etc. This is the question vector. This black is the question vector. Similarly, these positives like table post, invoice item, post in all these things, these are considered as the right results or right positives that's needed to generate the SQL for this question. So we convert these each and every vector, each and every chunks, table chunk, field sum, everything into vectors. Let's see, okay. Each and every dots are representing the positives. Now, negatives. Those tables and fields that does not come under this list can be considered as negative in a whole schema. As you know, our schema contains millions of fields, tables, joins, right? So, for a specific user question, for this user question, when we convert into a vector, these positives are the right these positives are the right results in order to generate SQL query for this. So these are considered as positives. So in an embedding space with many schema vectors out there, this loss function, okay, with the help of this loss function, it helps to push these positives towards the question vector, near to this question vector, right? I think you're getting it. It will push these positives towards the question vector. These are also vectors, every tables, fields, joins, everything. But as you see, this is an embedding space, so there can be lot of other vectors too, representing the other tables, fields, joins, everything, right? Now with the help of this loss function, it will push away the wrong results away from the question vector. Every other tables and fields and all other details away from the question vector. Similarly to all other. Okay. Now after that, the right vectors would become closer to the question vector and the wrong results would go away from the question vector. So this is what we do for each and every specific user question and for their specific positives. This is how we train our data. We convert all these things to vectors, right? And in an embedding space, a space with vectors. In that space, we do this kind of task during training. So that is what the close function does. I think you got that concept. Now, we start fine tuning. This step, it will start training our model. We pass our training data, we pass our epochs, and we also pass our output directory, and we also passing the checkpoint path, checkpoint save steps. So checkpoints are something when we train our model. After training is completed, we will get an output like this. But at the same time, in the output display, we can see something like this. So we will get an output like this with the steps and training loss. When we set the checkpoint steps as 500, the steps will get updated after every 500 steps of training. I will show you in the here in this model fit code. You can see that we are passing a checkpoint save steps 500. After every 500 steps of training the model, it gets saved in our files. That means each and every after every 500 step, the checkpoint gets saved to our records. Okay. Now from this, we will get the 500 step. We will get something. We will get a training loss, maybe like something, and in the next 500 step we will get some other training loss. So from this you need to make sure you have to choose the step with a very low training loss. That means the one with a low value in the training loss can be considered as the one with a better accuracy. So from this you can see the third one is the one with a small training loss, and that specific checkpoint, this one, the step number 1500 can be considered as the one with a better accuracy. So make sure when your training completed, you should select that specific path, that specific checkpoint path from your files, because that will be having the better output. You can compare the output. There would be multiple steps. Out of the total step, you need to compare and choose the one with a small training loss, which can give you a better output. So here you see, I will show you a small sample how the output gets stored. I'm actually storing my training files in my drive. I'm going to connect to my drive now. See, this is how your output gets stored. This is the training folder, and inside checkpoints you can choose the one with the very low accuracy, low training loss, that maps the best accuracy. Okay, so this was the training code setup. Now moving to the next stage, which is how to evaluate your model. Before going to the evaluation step, we need to prepare our FIAS vector store. How to generate FIAS vector store for both master data and schema. Okay, how to generate the FIAS vector store for both master data and the schema. So first of all, we have to build the FIAS vector store. We are passing the folder where we store our enriched schema and our master data. These two files, as we already shown in here, master data and the enriched schema, we store them in a folder. We pass it here. Then we also pass our output directory folder where we need to store the updated schema data and schema vector store and the master vector store. You also pass the embed model name. Make sure you are passing the model path which you you have to make sure to pass the exact path that you mentioned here. Okay, because you need to use your fine-tuned model to generate the FIAS vector store. I already mentioned that, and I'm not going to explain the complete technical code. If you wanted that, we can schedule live webinar session. Now, when we execute this code, it will generate. We are loading the FIAS embedding model, and we are loading the embedding model here, and we can run this code, build FIAS vector store for the schema data and the master data, and we pass our embedding model and also the output path for both files. And when we execute this, we get successfully updated FIAS vector store stored in this new directory. As we already said in our training phase, we already discussed that with the help of that loss function, we will push the positives towards the quotient vector and the negative vectors away from the quotient vector. Now, this FIAS will search this vector store, this index.fias file, and it will return the vectors that are mostly related or closely related to the quotient vector. We convert this question, the user question, into a vector format with the help of our fine-tuned version of the model. And we already created our FIAS vector store with the fine-tuned version of the model. Now the FIAS, that means Facebook AI Similarity Search Space, uses a technique called HNSW. With the help of this algorithm, this indexing algorithm, it will search this vector store and it will return the one which are closely related to this quotient vector. And the reason why we are using the remaining files like index.pkl and the source id file, the reason is that, as I already explained, this file will only store the numbers, right? The vectors. Now we need to convert these numbers back to its text format. So whenever user asks for a question, like here, what is the status of the invoice for William Taylor? William Taylor is a customer. Invoice mapping to sales invoice, and mostly to sales invoice. From the whole intent of the question, we can understand that. And status should be mapping to the status fields. So model will be returning their respective vectors, right? But in order to get the exact text format, we need these two files. And index.pkl, this is actually a document store that will stores the text format for each and every vectors. That means each and every number format we stored in our index.fias, and where each and every numbers would be mapping to their respective text format, and such that when the user when the model returns the number format like this, maybe a list with the float numbers, etc. Now we need to check what is the text format for this vector. The model will return top k results. Okay, so there would be multiple results, etc. Okay, now total top k results would be there. Okay, top k, we can set the k value. If we set 10, we can get 10 results. Top rated 12, we can return 12 results. Okay, and now we need to convert these vectors back to their text format. So that's where source id file gives a role. So source id file stores the IDs. That means the unique identifier for each and every vectors we stored in this file, such that, for example, this specific vector would be mapping to this identifier, first number 1, and second one would be mapping to the second identifier, third one would be mapping to the third identifier, like that. Now we can check for FIAS will check the specific function, this specific file, and will check which is a unique identifier for this vector. Suppose if 890, if this is the unique identifier, using this unique identifier, we will check this document store, that is index.pkl, and from that we can get the exact text format for this specific vector. Now we can check what is the corresponding ID, unique identifier for this vector
using this file. And suppose if this is the unique identifier, we can map that to the doc store and we can check the corresponding text format for this unique identifier. Suppose if table sales invoice is the text format for this unique identifier, with the help of this FIAS vector store, we can finally return tab sales invoice. And also if the second vector, if suppose if the second vector is mapping to a identifier like 456, with the help of this function we get the identifier. With the help of this file we get the identifier for this vector. Now we can check the corresponding index.pkl and map this identifier to the respective text format. Let's suppose if customer name is the text format for this identifier, model will finally return that. And like that, this is how we use an embedding model and how we use a FIAS vector store to get the exact tables and fields for the user question in order to generate the SQL from our own schema. So now we cannot see any hallucinations or guessed fields or tables. This is how we use the RAG based technique, RAG retrieval. This is the retrieval stage, retrieving from the schema with the help of the embedding model, which convert the schema to the vector store, FIAS vector store. From that we will get the exact things, exact metadata that is needed for generating the SQL. This is how we are handling the FIAS vector store. I think the concept is clear. This file will store vectors only for similarity search, and this file will store the text format documents, details of each and every vectors. This store the unique identifier in order to map the respective vectors to the respective text format. I think the concept is almost clear. So when we run this FIAS vector store creation code, finally we will get a folder. Like for master data, we will have entity FVS, schema, FVS maps to schema FIAS vector store. Inside that we can see these three files. One is index.fias, second one is index.pkl, and the third one is source id to idx.json. Now we can move to the next stage, which is comparison and evaluation.
Evaluation and comparison. Okay. Evaluation and comparison means we are just evaluating the model after fine tuning just to make sure the model performs better than the older version. Okay. If this is the first time you are testing your model, there won't be any old version to compare, but you can compare with the base version. I mean the model modern but embed. You can compare the base model with your fine-tuned model, and if you already completed the first stage of fine-tuning, then you can compare the second stage of fine-tuned model with the first stage of fine-tuned model to check if the model improved even a little bit. Okay, now I will show you that part of code. So this is the code for comparison using our validation dataset. We pass our validation data with unseen questions, which is not present in the training data, and we also pass the third phase of fine-tuned model and its corresponding vector store, and the fifth fine-tuned model and its corresponding vector store. Now we compare these two, third and fifth version. Then this is a base and fine-tune. Base is the old version and fine-tune is the new version. You can see there is a 2.56 lift up. Even if there is a small improvement, you need to make sure that your model is performing better than the older version. After that, you can push your model to Hugging Face. Now, how to push your model to Hugging Face? As I already explained, how to generate the token. I think I already explained how to create a model repo. Following this step, once you create your model repo, you can copy that particular path and make sure you need to paste it here. First of all, you need to authenticate. As I already explained how to create the access token, you can go here, click on access token, generate your corresponding access token. And when you run this, you will get a message like this. You can paste your access token here, enter, and then after you can run this code. In this code, you need to pass your own model repo created with Hugging Face. Then here you have to pass the path where you saved your fine-tuned model. Okay, I saved the checkpoint 1150 because I have low training loads for this checkpoint. That's why I specifically mentioned this particular path. Once you successfully executed, you can go to your corresponding repo and inside files and version, you can see your files get updated. Now this is empty. I will show you a repo or how it looked like. Okay. Once you push your model, your files and versions get updated like this with different with the different files for training your model. Now I think that evaluation and comparison is also clear. How to push your model to Hugging Face is also clear. Now we are going to explain how to deploy your model via replicate. And eighth step is deploy via replicate. The first episode, Farooq already explained what is an abrupt replicate, how to set up replicate. It's an AI server where you can deploy your AI models with a good GPUs. Now let's go to replicate. And in order to push your models to replicate, this is the dashboard. You can see the models, can see your predictions, you currently which or how much predictions you've made. You can evaluate their status, all of that from here. I will show you the files that we have to create for pushing our model to this replicate. And in order to set up a replicate AI server, you need to have one with a Docker, because every model we push to replicate, we wrap it in a Docker container. Now we have these different folders. This is the Shanghai Qwen 3, where we have the SQL generator model. We deploy our SQL model via this model repo. And Shanghai retriever, this is the schema retriever. This retriever, our embedding model is here. Our embedding model, which retrieve the relevant schema tables, all of that, we have the code inside this one. An entity retriever, the master data, the same embedding model, everything is same, but only difference is we have to use a master data file as vector store here. You need to use schema file as vector store here. First of all, let me show you the files for Shanghai Qwen 3 for SQL generator, where we use our Qwen 3 model. You have to make sure these two are the important files that you need to have. CogYAML stores the packages that you need to that you want in order to run your predict.py file. Here we are passing our model ID, and we already created a repo in Hugging Face for our large LLM for SQL generation, and at the same time we are using its smaller version for multiple other tasks too. In this video, we will be explaining only the important things, and in the coming videos, we will be explaining the backend API calls. At that time, we will explain the purpose of using this model. Okay. In this file, you can see we are passing our LLM, Qwen 3 LLM, and its large version, 4 billion version, and the 1.5 billion version. The smaller version we are using for doing some other task, like we use it for rewriting the user response, which is in the list and dictionary format, into a better user-friendly format. We use that model, this model for that specific task, and this LLM for generating the SQL. We also use it for rewriting a user question based on the chat history. So that part we will be explaining in the coming videos when we explain the different API calls we are making. At the point when a user sends a message to the final endpoint, where the user gets a results from the AI bot. Now you see, these are the running of, we run the LLM model, we get the output IDs, all of that. Now finally, we are passing a prompt. Actually, this file do multiple tasks, not just the SQL generation or not just the user-friendly format task, and it is doing a DB formatter, that's the user-friendly format, and it's also rewriting a user question based on the chat history. I will show that. As you see, when a user types a question like this, suppose if the user typed a question like this, items that are currently out of stock. So model returned some items, bot returned some items, okay, which are out of stock. But at that next time user is asking, show only for main warehouses. Okay, main warehouses. At that time, the user does not mentioning the full question, right? So we need to rewrite this user question to complete format like this. Items that are out of stock for main warehouse. Okay. So now the question is complete. You see, if the model gets this only as a question, model does not know what the user completely asked for. So we have to rewrite the user question based on the chat history. So we are using the same, I think we are using the large model itself here for that specific task, like rewriting the user question based on the chat history, the same model. So actually the 4 billion model of the Qwen 3 version we are using for two tasks. One is for SQL generation and the other one is for this rewriting of a user question based on the chat history. Okay, I think you understood the concept. When a user types a question based on the previous chat, that single question does not make a sense, right? Only if we provide a chat history, we can get a meaning for that specific question. So that's why we are using the same 4 billion version of Qwen 3 for rewriting that latest question based on the chat history. Now the question would look like complete, and then we pass this question for SQL, for schema retrieval, SQL generation, all of that. So we are using Qwen 3 for two tasks. One is Qwen 3 4 billion model for two tasks. One is for SQL generation, the other one is for rewriting the user question based on history. Okay. Now Qwen 3 1.5 billion, which is a lightweight model. We use it for formatting the DB result. DB result means when we execute the SQL query in our system, we will get the result in like dictionaries or it may like a list. So we need to convert that into friendly format. So that's where we use this lightweight model. And along with that, there are some other multiple small tasks are coming in between this. For that also we are using the same model. And in our tab, you can see this is our chatbot UI, and here there is a support tab. We are currently we are working on that. We write some queries for support team, which send to the support team, which wrote that specific request based on the type, like create ticket or get ticket details, like that. We are working on this. So in order to classify that specific query based on the intent, whether it is to create a ticket or whether it is to get the ticket details, we are using the same lightweight model here. We will come back to our specific area. Now coming to this, so this file store these specific details, and based on the task and based on the prompt, it will map that specific task. Okay, I think you got this one. Yeah, you see, so different tasks are there. One is for SQL generation, rewriting question, formatting the DB result, and also classifying the support request, whether it is to create ticket or to get ticket details. Yeah, we will update that. We are currently working on it. And now coming to how to push the model. Once you have this and you make sure the packages all are listed here, you can run cog push. Okay, make sure you are in that specific directory. I'm going to get into that directory. Okay, now you need to do what? You need to run cog build. Once you run this cog build, after that you need to run cog push. Okay, I'm going to run cog build. I'll come back after that. Now we successfully run cog build. Now we need to run cog push. When you run cog push, you have to mention your username and your model repo. Here the model repo is Shanghai Qwen 3, right? Shanghai Qwen 3. and our username is correct. So we mentioned that. When we run this, before that you can go to replicate and you need to check on that specific model path. You need to go to that specific model repo. Then here you can see the versions tab, multiple versions. The model, the latest one is D859 F91249. After push, it gets updated to the latest version. Okay. Once it gets updated, you can click on that specific version ID. Click on this copy model version name. Then you can go to your settings page. We are keeping a Shanghai settings Doctype where we store our API keys and version ID, model name, all of that. And we have these details. We save the model repo, dataset repo, and local server, remote server. And here this is a replication prediction URL. This is already public. And the version ID, this is a deployment URL. I will explain what is deployment. This would be the version ID. So once the version ID get updated, you can copy that one and go to your settings page and paste it in this SQL generated LLM version ID. Similarly, for schema retriever and entity retriever, we do the same thing. I will explain that. Or less actually the pushing is going on. That time I will explain this model repo Shanghai retriever. We are passing our file as vector store. This is the final vector store, and inside this function you can see this is the code. We are using our fine-tuned model as the embedding model, and we are passing the file as vector store, the schema file as vector store, because this is a schema retriever, and it returns in this format with a text, keyword, and metadata. Now the same thing, Coke build, and you need to get into that specific repo which is Shanghai retriever. Then you need to run Coke build and Coke push username and the specific model repo name. And when you push your model, you can check the versions tab, and you need to copy the model version name. And finally, you can paste it in both cases, entity retriever and schema. But make sure for schema retriever, we are using the files schema vector store, and entity retriever, we are using master files vector store. So we have that separate model repo here. Here also same logic, but different files vector store we are using. I think you understood the replicate files, how to push your model, all of that. Now inside the replicate desk, you can see there is a playground where you can run a small test case. From here itself you can run the model. Similarly for other models too, you can do that. For retriever, I will show a small example for entity retriever. Let me check. Actually, the model is currently in the code state. That means in order to load that model to the, in order to load the model from memory, we need to run a first test case. At that time, it will show a warm state here. Let's wait. Now see, we can see the output. The model, the entity retriever returned the data from our master records. You can see the table name and the complete exact value of that specific customer, A. Williams, because we just asked only Williams record. We does not mention the exact value. So model returned the exact value. Okay. Similarly, other results would be there. Now you see model is in the warm state. The model already loaded from the memory. Now when we run, there would be no lagging. We will get the output first. So because this is a lightweight model, it does not take too much time to get a response. Similarly for schema retriever too, we can run a question. We will get the output like tables, fields, all of that. Now let me show you a small example of that too. For schema retriever, yeah, where is it? Shanghai retriever. This is the repo. We named it as Shanghai retriever, but it is a schema retriever. Now I'm asking the model how many customers we have. So we need to return the customer Doctype, right? Our K is 15 here, so it will return 15 results. 15 top results. You can wait because now the model is in the cold state. we got a result where table customer is listed, customer name. Now we can write SQL with this data, right? Okay, I think these two test cases is clear. We have this as since this schema retriever embedding model is lightweight, we are not creating any deployment for this model, and it will take some few time to get your response, few seconds. But when it comes to large LLM like a Quen 4 billion model, it will take some time to get a response. So that's why we are creating a deployment, because whenever a model is in the cold state, it will take time to get the model, load the model from memory. But if it is a lightweight model, the model get loaded fast. But if it is a large language model, it will take some few time to load the model from memory. And even if we don't use a model for few time, it will reaches the idle state. It will reaches the cold state fast. So that's why we generated a deployment for this Quen 3 model. And in order to create deployment, okay, before that, I think you understood the concept entity retriever and schema retriever. Once you push your model to this replicate, you can use this as the prediction URL. You can paste this, but the version ID would be different based on your latest pushed version. Now, in order to generate the deployment, you need to go to deployments and you need to create a new deployment. You can give the details here. Okay, you can mention the name, you can select the model, Shanghai Quen 3. You can automatically the latest version get loaded. You can mention the GPU, and you need to set at least one instance in order to get a complete running of one exact copy. Once you do create deployment, your model will start running. This would be the cost. So when you generate a deployment, it would be displayed like this. You can click on your own specific deployment, and there is settings we can in the inside settings there is a property where we can enable and disable the model. Now the model is in the enable state. When we click on disable deployment, the model reaches the disabled state. That means the model deployment URL does not work on that state. Currently the model is in the enable state. That means it's already loaded from the memory. So whenever we write a question, whenever we write any question, the model start running. I'm going to test high. Okay, but make sure when you set your deployment as enabled, at the first time when you set your model as enabled, by this is currently model is now in the enabled state. I'm not going to disable it now, because when you run your enabled first, you need to run a small test case from the playground. The reason, because at the first time when the model is coming from the disabled state to the enabled state, it will take some time to load the model from memory, because we already disabled. At that time model will go to the memory, and in order to load from the memory, when we make it enable, it will take some few time to load the memory from memory. So that's why before going to the exact testing, you need to run a small test from this playground. Once you run that executed successfully, then you can start testing different questions. Okay, I think that that part is clear. Now we are going to our UI, and I will show some few test cases. So before that, once you created your deployment, inside the API tab, you can see your API URL. Click on this HTTP and you can see your API URL. This would be the API, deployment API, and you need to pass your own replicate API token. By clicking on this, you can create your replicate token. Clicking on API token, okay, and here everything would get updated. Version ID, okay, I think this part is clear. Now we can move to the real UI test case. Now I'm going to click on this chatbot toggle button. I'm going to ask how many customers we have. You can check on this debug tab in order to see the results. Yeah, this was the result from the system. We converted into a friendly format like this. This is the SQL query generated. When we send this, we can check the predictions tab. In this prediction tab, you can see the models models running. Currently this is the schema retrieving model. You can see the output here. Stock value difference, stock value, everything it returned. Now we can go back to our chat UI. Model is in the warming state. You can go and reload this again and see. Yeah, this is the final output we got. We can check back to the UI. Now we got the response. Stock value changed as follows over time. You can check the debug tab to see the SQL and the DB results, all of that. Now I'm going to ask the next question. Sales order pending delivery. Can go back to predictions tab. Load this. Processing Shanghai Qwen 3 model. The processing state. Can check each and every test case to see the debugging, to see the results in different stages. Now finally we got there are 4 sales order currently pending delivery. We got this. You can check the debug tab. I'm going to ask a comparison of sales this month versus last month. SQL generated test case. Now this is the, we got a final response. You can check the UI. Now let me ask to how many. Okay, show all employees. This is the SQL query, which is the Shanghai Qwen 3. This is the deployment URL. We get this response from the deployment URL. Now we can go back to these are the employments, their role. Can check the debug tab. This is the response from the DB from our system. The board converted into a friendly format like this. I'm going to ask to get all customers' names. This is the rewriting the question based on the chat history. We called that model at the beginning. We will explain that APIs in the coming videos now. Finally returned all customers' name in a friendly format. By this Qwen 3 model, we are calling that deployment URL where we have already loaded our Qwen 3 small and heavy model. Now you can see the customers are listed here. I'm going to ask show all items in stock. I don't know if it works or not, but still I'm asking. So some queries not work as expected because we are training. We are training the model. The model needs to learn your schema. It needs to understand different questions, styles, sort of that. Yeah. Then check the predictions tab. Finally, it returned the SQL. It will also run the Quent3 for rewriting the DB result. I think this is that one. Can process. Can load it again. Okay, something happened. I think the SQL was wrong. Yeah, some issues were there. So some queries still fail because we are currently in this beginning stage. We are training the model. So still some fields and tables, it have some errors and all. Now I think you understood the this technical implementation episode and how we train the model, how we prepare training data, how we prepare FAS vector store, how we train the model, push the model to Hugging Face, how we deploy the model via replicate, and what is the deployment, what is the deployment URL, how to get the URL. Yeah, one thing to mention, if you are not using your model, you need to go to your deployments and you need to disable that particular deployment. Otherwise, because whenever it's in the enabled state, it will cost per second. So make sure to switch off your deployment if you are not using it. Okay, I'm going to disable the deployment, but next time when you are wanted to use this deployment, not to run the model, you need to make sure to enable that deployment again from the settings. So you can go back to the settings and you can go back to the settings and you can click on this and enable. So at the first time when you enable that model, you need to make a small test case from this playground. Currently, since the model is in the disabled state, it is not showing the playground. But when you make it enable, you have to make a small test from the playground in order to load the memory, load the model from the memory. After that, you can make mini test cases, because at the very beginning it will take some time to load the model. So that why you can load the model, you can test, you can make a small test from here. After that, you can test from the UI. Okay, I think this video's the concept and the implementation all part is clear. And if you have any doubts and if you want more explanation of any part explained in this video, you can ask at support@erpgulf.com. We can schedule a live webinar session for that. If you wanted to contribute, you can do contribute. Actually, I forgot to mention our dataset repo. We have a dataset repo inside our Hugging Face in datasets. Can search for. This is our dataset repo. Hi, Mansur ERP. We have already added the details of the dataset repo, model repo in our README in our GitHub. You can look that. Here we upload our dataset. So far we used for training our model. If you wanted to contribute by sharing some training dataset, you can click on this files and version. You can go to contribute and you can upload files. You can upload your files here, then you can commit, make a playtest. So similarly, if you have any suggestions, if you wanted to make any improvements, any ideas, or if you faced some errors, bugs, or anything like that, you can report it via GitHub. Inside GitHub, you can go to pull request. You can share your ideas and suggestions. You can report your issues and bugs here. Okay, like this. I think this video gives you a small idea regarding the concept and the implementation part. If you have any doubts, you can ask at support@erpgulf.com or you can comment below. Thank you for watching this video.